Hi, everyone. Thank you so much for coming to this session on designing human-centered AI products. My name is Kristie Fisher, and I'm a UX researcher on Google Ads, and I'm also a contributor to the People+AI Research team.
Thanks. And I'm Jess Holbrook. I'm one of the leads of our People+AI Research team here at Google. We usually go by the acronym PAIR, so I'll be calling us that from now on. And the PAIR team looks at human-AI interactions across a number of domains. And there's something that we've noticed recently that I'm guessing you have as well. AI is everywhere right now. AI is everywhere. It's in the products that we use every day. It's at the forefront of just about innovations in just about every industry we can think of. And obviously, we're seeing more interest in AI development from developers like yourselves than we ever have before. But beyond that, if you're at I/O, we're guessing that you want to accomplish a couple things. You probably are interested in AI if you're in our session, of course. But we're guessing that you want to do something big and important with it. And we're guessing that you actually want to put the user first at every step of the way. At the same time, every developer wants to manage their time and resources to make sure that they're building something that people are going to love, that works great, and that you can build a business around. And so today, we're going to talk about a resource that we launched today to help you do both of those things. We're calling it the People+AI Guidebook, which is live today, ready to go, and something that we've been working on for about the past year. The guidebook is a toolkit that you can use to ensure that the time and energy and resources you put into development can make AI development can have a big impact and put the user first the entire time. It's the result of contributions from over 100 Googlers, and is really a synthesis of everything that we've learned about how to practice a human-centered approach to AI over the past few years. The guidebook sits already in an ecosystem of resources. We're not the first piece of guidance around AI that Google has provided to you. So the best way to think about the guidebook is on one side, we have the AI principles. These are our North Star. These are what guide every major decision we have. On the other side, we have the basic frameworks and tools that you already know, TensorFlow, MLKit, all these things. The guidebook is really a connection between the two. It's a way to actually put a lot of the AI principles into practice and a different way of approaching your work when using the tools that are out there. It's a way of working versus another technical guide or design spec or something like that. The guidebook has 6 chapters, which really cover the entirety of the development process, from identifying and defining user needs and success, to how to collect data to build the right kind of AI model, how to explain your AI to users once it's been developed, all the way to the inevitable failure of the AI, and how to do that in a graceful way where people don't abandon your product and still want to continue to use it. One of the things we're really proud of as well is the guidebook content is very tactical and hands-on. You should be able to go back. I feel like you should be able to read it in the morning and go back to your desk in the afternoon and put it into action. It's chock full of worksheets and things that you can print out and use with yourself and your team as well. There's more in the guidebook than we could cover in one talk or many, many talks. So today, we're really just going to focus on 3 chapters and 1 insight from each chapter that we think are some of the most important ones to think about if you want to be practicing developing AI in a human-centered way. First, we're going to pull from the user needs and defining success chapter and talk about how to identify if AI even adds unique value to your product. Despite what you might hear, you don't have to add AI to every single thing that you're building. Second, from the data and collection and evaluation chapter, we're going to talk about how to translate the user needs that you identify into data needs, finding that data, and training the right model. And from the explainability and trust chapter, we're going to talk about ways that you can explain your AI and what your AI is doing to users in ways that they will understand and feel in control while using your product. So to start, we're going to talk about how to identify if AI adds unique value to your product. And to do so, we have to walk through a few big questions you have to ask yourselves. So first is there a user need and associated pattern of behavior with that need? Next is there a definition of success to optimize for? In this one, we know that there's lots of metrics you could optimize an AI for, but we're going to talk about how you do that in a people-centered way. After that, we're going to look at how you think about, given the scope of the need you've identified, could a non-AI solution work? Like I said, we don't have to AI every single thing. And lastly, if AI is needed, which type is best? AI exists along many different spectrums. One of them is really from almost automation to augmentation. We'll kind of talk about those two ends. A lot of this is shifting the mentality from a technology-centered one to a people-centered one. One of the ways we think about this is right now, a lot of people approach a problem and say, can we use AI to blank, whatever they're thinking their business problem is. And it's really moving to how might we solve blank or solve for blank? And then can AI solve this problem in a unique way? That's moving things to a much more people-centered version of AI. So everything I've said so far has still been a little abstract. And one of the ways that we hope that we can really communicate this clearly to you is through an example. So just to kind of start us off and get everybody a little loose, who here flew to get here to I/O? OK, quite a few people. Kristie, yeah, me too.
Yep.
And of the people who flew, how many of you did some research to figure out what was a good price for airfare before you came here? OK. And then lastly, did anybody use Google Flights to do that? OK, a few. Thank you for the business. We appreciate it. So Google Flights team, the Google Flights app has a feature called Flights Insights. And so it's a feature that uses AI to help you know when the best time to buy a flight is. And this team actually used insights from the guidebook and the guidebook itself over the past year to build this feature. So throughout this talk, we're going to introduce some guidance from the guidebook, but then use the Google Flights case to really ground it out and let you know how another team already used this, this content. OK, getting back to the 4 questions we just had there. So first, you need to ask yourself, is there a clear need and associated behavior pattern? If you're at all familiar with human-centered design, it always starts with starting with a user need or a human need or a person's need. Starting with there is basically guaranteeing that you're going to find something interesting along the way. It may not be that exact thing you find at the beginning, but you will get there. If you have the ability to do formal user research, we of course encourage that. If you don't have that ability or don't have the resources, just talking to some of your current users or prospective users will really help you understand their needs. Then there's this associated behavior pattern. One of the really interesting things there is it gives you a baseline for the state of the world, but it also starts to give you the scent of the trail that you want to be on to find the right data that you'll need later to train your AI model. In the flights example, they were if we go to the flights example, they had a really clear need. They knew from their user research and talking to their customers that people wanted to know when to book a flight for the best price and not get burned. They also had a really good knowledgeable, they already knew the pattern of behavior people were using at the time. So people would go back to the same sites over and over again at different times because people were trying to figure out when is the best time to buy. Is it Tuesday night? Is it Saturday morning? Is it a full moon? I don't know. I can't figure this out. And so they had some data there, and they had some needs that they knew that they could address. Next, they moved on to, is there a clear definition of success to optimize for? So we all know metrics like views and some engagement and clicks and things like that. Defining success in a people-centered way is a lot harder than you might think. We spend a good amount of time on this in the guidebook. You want to be focusing on some harder to measure but more important things. Like, are you increasing your users' well-being? Are you increasing their long-term success and long-term engagement with your product? And things like, are you making them happier? Are they enjoying your product so much they're going to go tell somebody about it? Which is a lot harder. You also want to make sure, sorry, behind one. You also want to make sure and watch out for secondary effects. So some of the secondary effects are things like, what if you're too good at the metric you optimize for? Or what if it's done in a malicious way? So one of the ways that this happens is like clickbait articles. Like they have really good engagement and they have all these numbers, but they actually disappoint a lot of people and are negative for the overall ecosystem. And we get into this a lot in the guidebook. Another way you can think about defining success is through the good old confusion matrix when considering any kind of AI model. I'm guessing we're not going to get into this in any depth here, but this kind of underlies a lot of the predictive AI models, where you have the reference, which is the true state of the world, either something is or isn't in a category, and you have the AI prediction that it is or isn't. And so there we have our true and false, true positives and negatives, and our false positives and negatives. In a typical model, those are considered equal. But when you're thinking about the user experience, you may actually want your model to focus on one versus the other. So if we move back to the Google Flights example, this was their confusion matrix for flights prediction. So they're trying to predict, is the price of a flight going to go up in the future? So we have our two outcomes here, that the price, in fact, does go up in the future, and the AI model thought it would, and that the price does not go up in the future, and the AI model thought it would not. All good, no problems there. When we get to the errors, though, something interesting happens. So in the case where the model predicted the price would go up, but it didn't, that's actually not that bad of an error, because the person would just buy the ticket at the best price they could, but maybe just a little earlier than they had to. Not all that bad. The really bad one is when there was a price increase and the model did not think there was one, right? Because this could cost somebody a lot of money or even miss their flight or something like that. We don't just have guidance, we also have a lot of tools to help you actually inspect the data. One of those is something from the PEAR team that's called the WhatIf Tool. So the WhatIf Tool allows you to upload and dig into your data and explore the consequences of false positives and negatives, allows you to examine different precision and recall thresholds and associated trade-offs, and even compare the output from multiple models. So you can start to understand the errors an AI model is making, for whom and in what context a lot better. So going to the flights example, is there a clear definition of success to optimize your AI for? Success, yes. Buying at the right time at the right price was the clear success for them. Definition of success for them. Was there something they could optimize for? Yes, the best time to buy. And like we mentioned, it was all about avoiding those false negatives or those cases where the model did not think the price would go up, and it did. Next, we want to consider, given the scope of the need you've identified, could a non-AI solution work? The Google Flights team had a non-AI solution in place, but it was extremely hard to maintain, and the accuracy was hard to keep at users' expectations. They also have millions of daily active users and cache flights up to a year in advance, so there's a huge complexity to their need. So the scope is appropriate. AI is needed because there's just too much complexity to scale their current solution to their users' needs. But still, it was really grounded in that maintenance of meeting their users' expectations and the engineering sustainability of a heuristic versus an AI option. Now we're at, since AI is needed, which type is best? So AI tends to be better at, humans are good at certain things and AIs are good at certain things. When we think about the spectrum of AI and how it can help out, there's two kind of useful categories. One is automation and the other is augmentation. Automation tends to be, automation is just automating a task essentially away. Augmentation is a way to extend people's abilities, but they retain agency. So for automation, it's very good when people don't know how to do something. People literally can't do something. So for example, if you said, process these millions of rows of flight data, a human just can't really do that. Or if a task is boring, repetitive, or dangerous, something like maybe measuring air quality in potentially toxic areas. Augmentation is often preferred and better when people enjoy or feel responsible for a task, like writing a birthday card. There are high-stakes situations or complicated personal preferences. In the flights example, it's both a high-stakes situation and there are complicated personal preferences. High stakes because flights are expensive and getting to a family wedding is important. Kristie flies out tonight to a wedding, and she can attest that it's very important that she gets there on time and not late in any way. So we got to make sure we end on time. In terms of preferences, there are many complicated personal preferences, as everyone likes to fly in their own way. One of the big divisive ones for the flights team was overnight flights. Some people really, really love overnight flights. Some people will never, ever, ever go on an overnight flight no matter what. And so they really wanted to augment that person's ability to make that decision versus make it for them. So what did the Google Flights team do to identify if AI adds unique value to their product? They identified people's needs and behavior patterns. They defined AI success in a people-centered way. They determined if the scope of the problem needed AI and determined that it did. And they decided on the right type of AI to augment people's ability to make those decisions. And so once they identified that need, it was time to translate that need into data. And Kristie's going to tell us about how they did that.
Thank you. So a big thing that we learned synthesizing all of our knowledge across Google about building people-centered AI is that it's often very tempting to look at the data that you have and then say, what kind of AI could I create from these data? But that is really doing yourself and your future users a disservice. The right thing to ask is, given my user need, what scope of data would I need in order to then train an AI that could actually meet that need well? So if you don't take a step back and go through that human-centered design process, you're going to end up with an AI that maybe works great but doesn't actually do what people need it to do. So to avoid that, we want to make sure we are translating our users' needs into a data set that can be used to train our AI. So how to think about doing this? The first thing to do is to ask yourself whether users' needs align clearly with AI outputs that an AI could actually provide. Then you need to think about mapping those outputs onto a data set that you actually have access to. Then you need to think about, given the data set that I need, can I source it in a way that is responsible to make sure that I have no fairness or bias issues in my data, and to make sure that my data set is robust enough to actually train a model that will work. And then, of course, you have to do the really hard stuff that there's a dozen other talks on here today at I/O, which is build and train your model. But then as you do that iteratively and tune your model over time to get better and better, we're going to challenge you to do that in a way that really keeps people in mind and is not just focused on getting to a certain statistic. So let's start by thinking about how to align users' people's needs with data. So this is really simple. It's really just taking a few hours, talking with your team, thinking through it yourself, going back to that research you did with people, and thinking carefully about all the different parts of the need of the person who will be using this. Then thinking about, given what they need, what could an AI output be that could meet that need? So for example, on the flights team, as Jess mentioned, the real big question that people had was, when do I need to book this? Is it going to go up tomorrow, or can I wait and maybe get paid first before I jump and buy that ticket? So in order to meet the user's needs, the AI output had to provide, first, an understanding of what the present price is. Is this current price low, medium, or high? Then they also had to say, what do we think will happen in the future? Is it going to go up? Is it going to go down? Or is it going to stay the same? So in order to actually meet the user's need and help them buy a flight at the right time, the AI output had to provide these two key things. So once you understand what the AI really needs to do to meet the person's need, then you can start thinking about what sort of elements need to be in your data set in order to then train an AI that can deliver those outputs. So as many of you probably know, if you are experimenting with machine learning in your own development, structured data sets are a really common way to train models through supervised learning. And structured data sets contain examples. Examples are essentially the rows of your data set. And those examples contain features, which are the categories of information in your data set. And then lastly, you have labels. Labels are often qualitative bits of data, and they're often generated by people. So as you think about what data do you need to be thinking about, can I get a data set with all of the features that would be required to get an AI output that would meet my user's need? And can I get all of the labels that I need to meet that need? So for example, for the for the flights team, if they only had price data about what the historical price was, but they didn't know what day it was today and what the price was today, then that wouldn't really give them what they needed to meet people's needs. People need to know both what is the price today and what was the price in the past in order for the AI output to give them what they needed in terms of putting the price in context and knowing what would happen in the future. So you really need to think about, can I get all of the right features in my data set that could then lead me to an AI output that would be valuable to people? And then once you know all of the data that you need to train your AI model, now you actually have to find it. And this is no easy task. So for the flights team, they already had a heuristic-based tool in place before they decided to try to use AI for flight insights. And even then, with all of this data that had been coming in for many months and years, it still takes a lot of time and effort, as many of you know, to actually clean up that data and restructure it and make sure that it's in the proper format to then train a model. But for you, you might not even have that huge pool of data sitting around like Google does, so it's going to take you even more time and effort. If you've never worked with machine learning and AI before, you might not realize just how much time and effort this takes. But please know that this is the best place to spend that time and effort, because really making sure that you have the right data that can then deliver the right AI outputs that can then meet the person's need is going to make all the difference. So some key things to ask yourself as you're going on this quest for your data is there a publicly available data set that I could use, or do I have to build one from scratch? And then, does my data set contain enough example diversity to give me the types of AI outputs that I need? So for example, again, thinking of flights, if they're going to be able to provide meaningful insights for anyone across the world looking for a flight, they need millions of examples of historical flights, including all the features we talked about, where the flight was originating from, where it was going, how much it cost, when the ticket was purchased, all of that stuff. And then lastly, is your data set free of issues with privacy, fairness, bias, etc.? So each of those big questions could, of course, be a series of I/O talks, and there's many specific talks about these today and tomorrow as well, and probably yesterday. So we're not going to go into all of that detail, but we just want to remind you that we have a lot of resources on Google AI, as well as provided by the PEAR team, and some tips in the guidebook for building your own data set, making sure you're using all of the possible resources that Google has made available to make sure that you're getting the best possible data to train your model. And there's one tool you might not be aware of yet called the Facets tool. The Facets tool allows you to visualize what is inside of your data set before you put it into your model to train your ML. So what's really helpful about this is when you suddenly see all of your data categorized and colored, it can be really obvious if something is missing or if there's a disproportionate amount of one category of data versus another. The flights team was actually able to catch a few errors itself by using this tool. So you finally figured out what data you need, and you spent all the time getting the right data set and building and training your model. Now you have to make sure that you can continue to tweak and tune it to make it as accurate and as reliable as it can possibly be. And as you do this, we're going to give you a framework for how we'd like you to think about this, to do this in a way that's people-centered. So that framework is this. If some metric for our AI changes, the delta drops above or goes below a certain threshold, then we're going to take a certain action. So what this meant for the Flights Insights team was if bookings from this new AI-powered Flight Insights tool dropped below a certain percentage, so people weren't using it, they weren't finding it valuable during the beta phase, then the flights team would needed to do something about it. They needed to then perhaps adjust the confidence to make sure that only the highest confidence flight insights predictions were actually making it in to the Flight's Insights UI. So what the Flights team did to translate user needs into data was first make sure that the needs of the people who'd be using Flight Insights could be aligned with AI outputs. As we said, those AI outputs are a current understanding of the existing price today and a prediction for how that flight will change in the future. Then they had to map those AI outputs onto a training data set that they could actually acquire. Make sure that it was sourced well and didn't have any issues. And lastly, they had to continue to tune and iterate on the model in a way that was people-centered. So now you might think, we've really done the hard work. We have built an AI that works. Like, that is so hard. It can take months. It can take a team of engineers a really long time. Even with all the tools that we've made available at Google to democratize AI, it can be really hard. But unfortunately, there's still more you have to do, I'm sorry to tell you. Because if you build a great AI, but people don't understand it, then you risk them misunderstanding your model, using it incorrectly, or simply ignoring your AI product altogether. This is something that I think about every day, because on the Google Ads team, we build really complex AI-driven forecasting tools that can help advertisers make really hard decisions. But if they don't understand what went into this forecast and how they're meant to use it and how confident they should be in it, then they're not really sure how to incorporate it into their workflows. So we're always having to work really hard to make it better. So for you, what to think about when you're thinking about how to explain your AI system to the people who are using it is first think about what explanations are needed to build something that we call calibrated trust. Calibrated trust means that somebody does not under-trust or over-trust your AI. Under-trusting is, this recommendation is crap, and I'm never going to use that ever. Over-trusting is, well, if the AI says so, it must be the truth. I will take it no matter what. So with calibrated trust, people know when they should use what the AI gives them without question, and when they should maybe double-check it or apply their own judgment. The next question to consider when considering how to explain your AI to the people using it is, what level of technical expertise do people have? Because people with higher technical expertise may need or expect more information about the AI in order to build that calibrated trust compared with people who are non-experts. So for example, somebody who's a neurologist who is using an AI system to help them diagnose a patient, they're going to really want to make sure they understand all the ins and outs of the AI and how it was programmed and what data it was trained on before they're willing to trust it, because their patient's life is in their hands. Meanwhile, if I'm just using maps to find my way out of here so I can get back to the office, I don't need to know all of the details of how Google Maps helped me get to this direction and this route. And lastly, you need to think about if and how to display your AI's prediction confidence. So most AI systems can generate some sort of measure of how confident they are in a given output or a given prediction. And how to visualize that to people and whether they need that information at all is something to think really carefully about, and something that we give a lot of guidance on in the guidebook. So first, thinking about how to build calibrated trust. Usually, people do not need to know everything, and sometimes full disclosure is less helpful than just the key pieces of information that are most important. So through doing research and through doing lots of testing and iterating, you will come to know what information the people using your product need in order to trust it and use it effectively. So typically, you're not going to give a full explanation of here's everything about how my AI system works. You're going to give a partial explanation. And typically, those partial explanations should include what sources of data were used by the AI. This is important because users need to understand when they might have information that the system doesn't have. So going back to that neurologist example, they need to know whether this prediction from the AI that this person has a tumor is just based on lots of imaging data from lots of people, or whether it's also taking the very unique patient history of this one person in front of me into account. Without knowing that, what the source of data is, it's hard for that neurologist to then trust the AI. And generally speaking, these partial explanations of AI should include inputs, outputs, capabilities, and limitations of the system. So this is what the AI is expecting from you, this is what you can expect to get back in return, and this is what it simply can and can't do. And as I mentioned before, and I will mention several more times before I give the clicker back to Jess, is that displaying the confidence of the AI system is not always useful to help the person use it effectively. So for the flights team, when we think about what information the users of Flight Insights needed in order to trust the system, they needed to know what airlines and options were or were not included. As Jess mentioned, if I am totally willing to take overnight flights in order to save some money, I want to make sure that the AI knows that and it's taking all of those options into account. And through research, the flights team learned as well that only very confident predictions were going to actually be useful to the people using Flight Insights. So if a prediction was only about 50% confident that the flight price would or would not go up, people didn't want to see that, didn't seem much better than what they were currently doing. So next is technical expertise. So thinking again about flights, obviously, we can assume low technical expertise. Whether even if you are only flying once a year, you could still use Flight Insights. It's meant for people all over the world who are in lots of different geographies and who do fly a lot, don't fly a lot, so you can make sure that this is understandable and in plain language that lots of different people can understand. So understanding the low expertise of the user, the flights team built a framework for communicating in plain language what the AI behind Flight Insights was predicting. So they started off building simple sentences that explained the current state of the world and what the AI predicted for the future. So for example, prices are currently either low, medium, or high, and then what the AI predicted would happen next. So to walk through a couple of examples, let's say prices are currently high, and the system does not have a high confidence prediction for what will happen next, if they'll go up or down. In this case, the Flight Insights tool might just say, prices are high. I don't have a good prediction for what happens next, but just so you know, for context, prices are high. If the Flight Insights model did have a good prediction for what would happen next, it would again explain this to the people in plain language. So prices are currently medium, but they will generally go up, or prices are currently low, and so today is a good day to book. As we already mentioned, displaying model confidence is not always useful. And lots of different types of displays exist, and every one has trade-offs. We unfortunately aren't able to give you the out-of-the-box solution of this way of displaying confidence for your AI will work for everyone all of the time. What we can tell you is, here are some examples, here are the trade-offs, and for you, you need to test and iterate a lot to get it right. So some common ways of displaying AI prediction confidence are categorical, in-best, numeric, and data viz. So in categorical, you're simply chunking your predictions into really confident, kind of confident, and not so confident. In best, you're giving a result, and then you're saying, here are some backups just in case we're wrong. So for example, here's a picture of Tokyo, but it might also be a picture of New York or Los Angeles or somewhere else. And numeric is simply giving the number that the system has given you. I am 88% confident that this recommendation is true. And data viz, you might show graphically what the AI's prediction is, and then put some confidence intervals or some error bars around it. And again, thinking about the trade-offs and again about the user's likely technical expertise, keep in mind that they don't need to understand the AI as well as you, the person that built it. They just need to understand it enough to know what to do next. So when you think of something like the numerical indicator, if you tell me that you're 88% confident I'm going to love this T-shirt, is that good or bad? Do I need to know that level of granularity? Is 86% that much better or worse than 88? So those are kinds of things to think about. So again, for displaying the AI prediction confidence for the flights team, they decided not to give any kind of indicator of how confident the system was. They simply decided not to display it if it was not confident. So instead, their design challenge was, how do we display only these very confident predictions in a way that's simple and usable and elegant? So here's what the Google Flights UI looks like. And if we zoom in here, here's the indicator that, again, explains in plain language what the AI is predicting. So here's the current price, and here's what we think will happen next. So to recap, you need to build calibrated trust with your users. You need to keep their expertise in mind when you're creating these explanations. And you need to decide and think very carefully about if and how to display model confidence. So that's how the flights team built this insights tool. Jess, how did their people-centered approach to AI design work?
Yeah, so the team took insights from the guidebook, took a human-centered, people-centered approach, and we can't share exact numbers, but things have been going really well. They get very positive feedback. And one of the most important things to know is when you build in a people-centered way, people will tell you that you did. People will tell you if you succeeded. There'll be very little guesswork. So to zoom back out from the Google Flights example, back to the general ideas, what we've covered today is a few insights from 3 of the chapters. How to identify if AI adds unique value for your product or your use case. How to then take that and translate that user need into data needs and requirements for your AI model. And then once you have a functioning model, how to explain it well to users in a way that they understand and that they can feel in control of what they're doing. Like we said at the beginning, there are 6 chapters in the guidebook total. Each has many of these kind of insights in them. And so there's just a ton more for you to check out. You can check it out here. We hope everyone goes, takes a look at it. We hope you use it. We hope it's useful to you. Really importantly, we really hope you send us feedback. There's a big feedback button along the whole thing because we want to make something that's useful for everyone out there. We really appreciate your time today. If you want to keep the conversation going, we'll be at the Material Design and Accessibility Sandbox at about 2:50 later on. So thank you very much.
Thank you.